Hello everyone and welcome to this session. In this session we're going to be discussing EIGRP. We're going to be talking a little bit about how it establishes its neighbors. We're also going to be looking at the configuration and also some helpful commands to review and troubleshoot EIGRP. EIGRP is a very well-known routing protocol. There's also other routing protocols that you may have heard of, such as OSPF, ISIS, RIP, or even IBGP. These are all routing protocols, and they're all IGPs, in other words, internal gateway protocols. And these are protocols that you would use within your network to route traffic from one location to another location throughout your network dynamically. And so today we're going to be looking at EIGRP. EIGRP is possibly one of the easiest protocols to get configured and get going because it really only requires two commands, and we'll be looking at those commands here shortly. But EIGRP will discover its neighbors whenever we enable EIGRP on the interfaces. So if we were to enable EIGRP on both of these interfaces, this router would begin to send hellos this direction, and this router would also begin to send hellos this direction. And whenever these routers receive each other's hello, they would start to create a neighborship, and once they establish that neighborship, they begin to share their complete routing table. They will share all the routes that it knows from one router to the other router. So router 1 would send all of its route information that it knows to router 2, and also router 2 to router 1. Once the full routing information has been exchanged, at that point they will send each other hellos. They'll send each other continuous hellos. Then this is how it's kind of more like a heartbeat, that it helps each other know that they're still there. So router 1 say, hello, are you still there? And then router 2 will also say, hello, are you still there? And so they will be talking to each other until there is what's known as the hold timer. So if the hold timer expires, so if router 1 is sending router 2 hellos, and it sends it another hello and then another hello, and router 2 never receives that hello, and then it's going to drop the session. And so that's where the hellos come in, and we'll be taking a closer look at those particular settings. And then the last section is the partial updates. So once the neighborship is established and the full routing table is exchanged, they're basically up and going. But if there was some sort of network event, if router 1 had a couple networks hanging off on this side, and one of these networks was to go down, then at that particular point, router 1 would send router 2 an update. And so the update is basically what's considered a partial update, because it only sends information about this one network that went down. Basically, router 1 will tell router 2 that it lost its particular network, and to not send any traffic to router 1 for that network. And so that's considered a partial update. And this only happens when there's an event. It doesn't do a full routing update. It just only does a partial update. And so this is a quick overview of the messaging and the steps that both of these routers go through in order to establish a neighborship. And it seems like there's quite a bit here, but in order to get this configured, there's really only two commands that are required. And we'll take a look at those now. So in our lab today, we have router 1s, 2, 3, and 4. They're all configured with /30s. And today we're just going to be working with router 1 and router 2 so that we can get a good understanding of the provisioning. So on router 1 and router 2, the only thing that I have configured are the interconnects. So if I go to their interface, we see that gigabit 00 and gigabit 01 are configured with IP addresses, and we also have a loopback that's configured with an IP address. All of these networks, these are /30s, and this is the /32, but they all fall within the 10.0.0.0 subnet. Same thing for router 2. This is all we have configured so far. So to get EIGRP running, before we configure it, I'm going to show you a few commands here so that we can see that there's nothing configured or running for EIGRP, and then I'll show the same commands once we have EIGRP running. So for example, if I do show IP EIGRP neighbors, there's nothing there. If I do show IP EIGRP interfaces, there's nothing there. Show IP EIGRP protocols, show IP protocols, there's nothing there. There's nothing for EIGRP. So I just wanted to show that so that, you know, everyone, so that we are in the same understanding. Same thing here. Show IP EIG interfaces. There's nothing here. Show IP protocols. There's no EIGRP protocol running. Show IP EIGRP neighbor. There's no neighbors. Okay. So to get EIGRP running, the first command that we have to enable is EIGRP, router EIGRP, and then we have to specify the autonomous system number. So the autonomous system number is important because they do have to match across all the routers that you want to run EIGRP on. So for example, in our case, we'll use 10 as the autonomous system number. So you can see here, it can be any number between 1 and 65,535. So we're going to go with 10. The next important command is the network. The network command basically identifies the networks that you want EIGRP to attempt to establish a neighborship on. So for example, in our net lab here, we have gigabit 00, gigabit 01, and loopback 0, all part of the 10, the classful 8 subnet, so 10.0.0.0/8. And so in our lab here, we're going to enable EIGRP on all of these interfaces. So in order to do that, I'm going to specify a supernet. So that's going to be the 10.0.0.0, which will include all of these subnets, and so therefore EIGRP will attempt to establish neighbors on all of these interfaces. And so once I do that, if we run show IP EIGRP interfaces, now we see that EIGRP process number 10 is running on these three interfaces. It's attempting to establish a membership or a peer with in all three of these interfaces. Now we can go to router 2. we can do the same command, config t router EIGRP, and then we have to specify the autonomous system, which has to match to router 1, and then we're going to use the network command as well, and we're going to create the supernet 10.0.0/8. And as soon as to do that, it discovers a neighbor 10.1.2.1 on gigabit 00, which we can see here. Those are the interfaces that these two routers are speaking on or connected with. And so if I do show IP EIGRP interfaces, now we can see that there is one peer on this interface here. EIGRP is still trying to, discover peers on these interfaces, but because we haven't enabled EIGRP on these other routers, it's never going to find a peer here. So the only two commands that we have configured so far, we can review this, is these two commands. And with these two commands, we now have a peer. We have router 1 and router 2 peering and exchanging routes. And so the way to confirm that is that we can check the routing table, show IP route. So router 1 here has learned of a couple subnets via EIGRP. So the letter D is the letter that identifies EIGRP routes. You can also do show IP routes EIGRP, and we'll see that, okay, it's learned two routes from gigabit 00, gigabit 00. This first entry here, 10.0.0.2/32, that is the loopback IP address on router 2. And we can see it right here, 10.0.0.2, and it should be pingable. We can copy that and we can ping it, and it's successful because we are learning these routes now via EIGRP. So we've looked already at some of the helpful commands. One of them is show IP EIGRP interfaces that we had just looked. This gives us some good information here. One key value here is the SRTT value, or the mean SRTT value. So this is the smooth round trip time, and this is a timer that's a good indicator if there's an issue downstream or between your peers. If this number is very high, there's possibly some sort of congestion or latency between the two routers. We also have the number of peers that we've learned. Another helpful command is show IP protocols. Now that EIGRP is running, when we run the command show IP protocols, now we see an entry here for EIGRP 10, and it gives them some information about this particular process. It says that it's routing for networks 10.0.0.0, which is what we configured using the network command. It's also let us know that the distance is 90. The administrative distance is 90. And it also gives us the metric weight values. And so these are the default metric values. We will look at these particular values in more detail. The router ID Basically, this is used to identify this particular router. Another helpful command is to view the timers. We can take a look at show IP EIGRP interface details gigabit 0.0. This is actually a very helpful command, and sometimes it's overlooked, but it's very helpful because it actually tells you what are the hello intervals and the hello timers that this particular router is configured with. In these particular case, the hello interval specifies, tells the router how frequent to send the hellos. So in this case, the hello interval 5 lets us know that this router is configured to send hellos every 5 seconds. The hello timer is 15. And so what this is letting us know is that whenever it sends this information, tells the neighbor router to wait at least 15 seconds before it determines that this particular router is down. So that's kind of key here to understand that the hello interval is, it tells this router how often to send the hellos, and the hold timer tells the far end how long to wait before it determines that router 1 is no longer reachable. So if we go and take a look at show IP EIGRP interfaces, see here, EIGRP neighbors, right here, we can see that router 2, the hold seconds right now is 10. So if this gets to 15, then it's going to drop the neighbor, because router 1 is saying set your hold timer to 15, but I'm going to send you hellos every 5 seconds, so it should never get to 15 unless we lost connectivity. And if they lose connectivity, then this will exceed 15 and the neighborship will be torn down. And so we can manipulate the hello timers and also the hold timer. These actually don't necessarily have to match on both sides. In order to manipulate these particular timers, we do have to go under the interface to make those changes. So we'll do that real quick here. So under gigabit 00, these are the two interfaces that we're using at the moment. We can set the hello intervals, and we have to specify for what autonomous system number. In this case, we're using 10. And then we can specify how often this router needs to transmit hellos. So as we saw earlier, it will set to 5 seconds. So we're going to go ahead and say 10 seconds. And then we're going to specify the hold time. And so the hold time is the seconds before the neighbor is considered down. So in this case, we're going to, typically best practice is to multiply times 3 whatever your hello timer is. So in this case, 30. And so if we look at our interface now, here for EIGRP process 10, we set the hello interval to 10 seconds, and we set the hold time interval to 30 seconds. And so if we go to router 2, Before, this was 15 because it was initially set to 5. So now if we do EIGRP neighbors, now we can see that it's starting to count down from 30. So it's going to 35, 25, and this should never hit 30, because if it does hit 30, then the session will go down. And so we can see that we still have a neighborship. Even though we changed the timers on router 1, the neighborship is still up. So that tells us that we can have one set of hello and hold time settings on router 1 and different ones in router 2. In best practice, is really always great. It's always good to keep them the same, so that you can prevent any sort of inconsistencies or any issues. So typically, I leave them the same unless it's required for specific reasons. Maybe you're working in an environment where there's very low speeds, and then maybe you want to change your hold timers and your hello intervals. But for the most part, just the default settings work great. And the last command I wanted to show was the show IP route table. Here is a good place to see what routes you're learning from EIGRP. We can see here this router is also learning a couple routes from router 1. And so this is how we know that we are learning routes successfully. Well, this is all the commands and quick configurations. This is more of an introduction, and I hope you did find this video helpful. And if you like it, please subscribe or leave a comment. If there's any other particular topics you would like for me to cover, please leave a comment. And if you want to get notified when my next video comes out, please subscribe. Thank you and have a great day.